Carbohydrate. Role of carbohydrates. Carbohydrate is the first product of photosynthesis. So this is the materialized energy form from sunlight. That's why carbohydrates are the energy source and storage device. Also, some of those carbohydrates provide structural components. Also, very importantly, the cellular recognition is also presented by carbohydrate structures. Glucose. Glucose is the first product of photosynthesis. And molecular formula of glucose is this. Looks a little complicated. Well, glucose is composed of 6 carbon and 6 oxygen and 12 hydrogen. If you rewrite this like this format, seems like there is some trend. And even we can make it even simpler like this. And we realize that all the carbohydrate structure is actually this form. Now one carbon and water molecule. Carbohydrate is composed of carbon and water. If you look at the name, carbohydrate, this means hydrated carbon. Now that is the definition of the molecule's name, carbohydrate. Then we can think about the synthesis of carbohydrate by this simple formula. Maybe carbon and we can add water, maybe we can generate glucose. It's amazing, isn't it? So maybe just the coal material and the water, we may need some kind of a magic catalyst, such as philosopher's stone. Well, for a long time, the alchemists believed we needed this kind of a special catalyst to make a gold. But modern days, maybe the 19th century's organic chemists, they believed that maybe utilizing this philosopher's stone, special magical catalyst, maybe just utilizing coal and by adding water, we can make the food material, glucose. Now here is another term of a monosaccharide. Monosaccharide is monomer of carbohydrate. That means here the saccharide is another name of carbohydrate. The simplest carbohydrate is a monosaccharide, just a six-membered ring with a six carbon. Looks like it's a simple, but actually glucose structure is quite sophisticated structure like this. Now, this formula of molecule C6H12O6 molecule not only make glucose. Here is the brother of glucose, galactose, which has exact same molecular formula. And here is a cousin, fructose. Fructose also looks like a little different shape, but it does have exactly the same molecular formula. Not only making those brother and cousins, D-glucose also has mirror image molecule L-glucose. So these molecules has the same physical chemical properties, but they have a different optical other property. D-glucose is a naturally occurring form, L-glucose is a purely synthetic molecule. So as you see here, even same molecular formula of glucose, it can generate many different kinds of different molecules. The molecules which have the same molecular formula but with different properties, we call them as isomers. So you can see those isomers of glucose is many. So that's why just a simple mixing of a carbon plus water with some catalyst, it's almost impossible to build new molecules. This open form of the glucose make a ring structure like this, alpha form. And if you change the structure a little different, even it can form beta form of the glucose. So this is a quite dynamic structure. They can interchange to each other and can form alpha and beta ring structure. Even it can form open structures. Monosaccharide can make a dimer, which is a disaccharide. For example, glucose and fructose, they can react with each other. And by removing one molecule of water, the reaction is dehydration reaction or condensation reaction. And they can form sucrose. Sucrose is the best known sugar to us. Originally, sugar means it's a carbohydrate, but usually we mean sugar as sucrose. Now here the connection point is we call glycosidic bond. Here the glycan, so they means it's a carbohydrate and glyco is the adjective form of glycans. Carbohydrate linkage can make different kind of the connections. So for example, in this case, this is a 1-4 connection, and numbering wise, this is 1, 2, 3, 4. So this is one position. Here, this is sugar, 1, 2, 3, 4. That's why this is a 1, 2, 4 connections. Now, if you look at on the right side, this is also 1 to 4, but depending on those positions, this is an alpha form and this is a beta form. That's why the connection is different. One is alpha 1, 4, the other is a beta 1, 4 positions. Of course, it is possible to connect this one position to different number of sugar connections. Let's say 1 to 1, 1 to 2, 1 to 3, 1 to 6. All different kind of a combination is also possible. Now we have seen monosaccharide to dimer of disaccharide. Even they can grow up to make a polysaccharide, the polymers. Here are two examples of a polysaccharide. Left side is alpha-linked glucose polymer, and this molecule we call glycogen, and this molecule is the energy source. Either glucose is synthesized by photosynthesis, or we eat glucose from the food, and then this glucose can be polymerized to form this stored energy form of glycogen. Very similar structure. If the glucose is connected to each other through beta linkage, and this cellulose molecule is very difficult to digest. That's why this molecule is resistant and it provides the structural component. So the rigid structure of plant, it is from cellulose. These two molecules chemically very similar to each other. It's almost like isomeric relationships, but only that small linkage difference. Alpha form make food, beta form make structural building blocks. So if you think about the function of carbohydrates, they are energy source or storage forms, or they can provide structural components like cellulose. Another important role of carbohydrate is molecular recognition. If your red blood cell has this kind of carbohydrate structure, this is A antigen, your blood type is A type. Now the end group here, A type has N-acetyl galactosamine, B type has just a simple galactose. Now this is a B antigen. Well, if you have both of them, now you are blood AB type. Then what is O type? O type is you don't have the end position of this sugar, so no galactosamine, no galactose. Now this is so-called O type of blood.